Hello everyone. In this video we're going to be solving an exponential equation. We have 2 to the power x squared divided by x squared plus 1 plus 2 to the power 1 over x squared plus 1, and that is equal to 2 times the square root of 2. And we are going to solve for x values. Now this equation may look very unfamiliar to you or very non-standard, but don't worry, we're going to crack the code. So when you have an exponential equation, one of the things that you should look for is, do we have the same exponent? And of course, you would like everything to be in multiplicative form. So for example, you want to have something like this: 2 to the power x over x plus 1 multiplied by 2 to the power maybe x, I don't know, equals 8. I just made it up totally. But can this equation be solved? Absolutely. You just need to use properties of exponents, which says, one of them says at least, if you are multiplying two powers with the same base, which is the case, then you just add the exponents. And that gives you an exponential expression with a single base and an exponent. A single expression, in other words, right? And that's the same thing we have on the right-hand side. Then once you get that, let's say you get something like a to the power y equals b, the next step, let's say we're solving for y in this case, either to use logs or something else. Something else meaning 8 can be written as a power of 2, which is 2 to the third power. So we can go ahead and do that. And once we get equal sides, like let's say we ended up getting something like a to the power y equals b, which can be written as c to the power y, with the same y being the exponent, then we can totally forget about b and just set these equal to each other and talk about a being equal to c. Why? Because if a is equal to c, then a to the y and c to the y are going to be equal. But you got to be careful about some cases because this is not necessarily true. Even though a and c are different sometimes, we can still get an equality. For example, if y is equal to 0, then a and c don't have to be equal. Or if a is 1 and c is negative 1, so on and so forth. There are different cases. We're not going to go through all of them because it doesn't apply to our problem, but I just want to give you a quick rundown on exponential equations. I'm planning to make a whole video on solving exponential equations. I'm not exactly sure when, maybe not in this channel, in another channel that I'm planning to start. But anyways, that's a different story. Let's get back to the problem. And of course, these are standard cases. So anyways, so we can kind of really simplify this problem and say something like, okay, what if we had something like this, right? And I probably shouldn't use x because you'll be confused, like it's not the same x. Let's just say 2 to the power z equals 8. This automatically means 2 to the z equals 2 to the third, and this implies z equals 3. I'm not talking about a complex number z here. Obviously, 3 is a complex number, but at the same time, it is a real number. By the way, speaking of complex numbers, I have another channel that focuses mainly on complex numbers, and it's called aplusbi. Hopefully you remember that, right? Anyways, check it out and let me know what you think. But let's go back to the problem that we have and see how we can solve it. Because I told you it is not a standard problem, so we have to use a non-standard method. And what is that? We'll talk about that now, okay? Great. Now, first of all, I want you to notice that, like I said earlier, the bases are the same. So that's a good thing. Obviously, if the bases were different, we would be in big trouble. So we would have to look for other ways. But in this case, they're the same. But not only that, we also have two exponents that seem to be related. What do I mean by that? If you look at this exponent and that exponent, guess what? They're both fractions, first of all. Second, they have the same denominator, which is beautiful. But do you know why it's beautiful? Okay, let me explain. So we're going to go ahead and combine these exponents in such a way that this turns into something super duper nice. Are you ready? Okay, let's get into it. So take the first exponent and then take the second exponent. And what do you think we should do with these? Add. If you said add, you got it. Why? Because first of all, these are two fractions with the same denominator, so adding them only makes sense. Second, it's like today is going like first, second, right? When we add them, the numerators add up to x squared plus 1. And we get 1 from here. That's awesome, right? Did you know that? Well, it's not always easy to see. That's why I kind of wanted to take you through a little tour of how you can get there. Because a lot of times when I skip through things, people complain and they say, oh, why did you do it so quickly? So you don't have a plan. We don't get it. We don't understand. And I totally understand. I'm not against that every time you don't understand something, you should ask questions. That's the best way to learn, and I'm pretty sure somebody will answer nicely. If not, let me know. Okay, so basically, what was I saying? Yeah, so if I just skip through steps, that's not good. If I do it too slow, it's not good for some people. So it's really hard to, you probably know that expression, right? It's impossible to please everybody. So, at some point, somebody will complain, but that's okay. Anyways, so I like to explain steps. That's what I'm trying to say here. Maybe I took too long to explain it. But once we get 1, this is really cool. You know why? Because now these two exponents add up to 1. So we kind of have something like this. If I call this A, and if I call this B, I get something like 2 to the A plus 2 to the B equals 2 root 2, which doesn't look any better. But guess what? A plus B is equal to 1. That's the beauty of it. So we can kind of write this as a system. Isn't that awesome? So from a single equation, by way of substitution, which is kind of simple, we arrive at a system from an equation to a system, but it's actually easier to solve. How? By way of substitution again. That's why I always say substitution is awesome. So underrated. So here's what we can do. We can go ahead and isolate B and write it as 1 minus A. And that's something we can use. Like right here. Plug it in. Yay. So now we get the following. 2 to the A plus, are you following? 2 to the B. 2 to the B is 2 to the power 1 minus A because I'm replacing B with 1 minus A, remember? And that is equal to 2 root 2. Now again, we did this, but why is this so good? Does it look any better than the original? Absolutely. Because the original problem was a mess. And I wanted to put that in the thumbnail. Do you think this is an equation or a puzzle? Let me know in the comment section down below. So once we get to this point, things are actually really, really nice. You know why? Because we can go ahead and split this up. If exponents are subtracted, work backwards with the exponential rules, then this is division. That comes from division, right? And now 2 to the power 1 is 2. And we can do, okay, it's amazing, right? I mean, if you use substitution, or what can I do? I can't help it. It's amazing. It's beautiful. So now let's not use B. Let's replace 2 to the A with something else. How about U? Okay, great. So that's for you. If it's your birthday, happy birthday to you. U plus 2 over A. Oops, sorry. This is also, oof, what did I do? This is also U, right? Not A. So let's fix it. Equals 2 root 2. Okay. Now what is this? Multiply everything by U. Oh, so close. 2U. Okay. I said that already. Now we can go ahead and put everything on the same sign, and guess what? This becomes a quadratic equation, finally. Something we can manage, right? Now let's go ahead and solve it using either the quadratic formula or completing the square, whatever you like. But I'm going to write it as, I'll use the quadratic formula. Negative b plus minus the square root of b squared, which is 8. By the way, you should know that this squared is 8. Minus 4ac. Oh, that's also 8. That's interesting, right? Divided by 2. That's 0. When does that happen? When delta is 0. There are 2 roots, but they're equal. So there's only 1 root. And that is root 2. Why is that happening? There's an explanation. If you go by the completing the square route, this is actually u minus root 2 quantity squared equals 0, which has only one solution. 2 solutions, but they are double or something like that. So u equals root 2, but we have to go back and replace 2 to the a with u. 2 to the a is root 2, which is 2 to the power 1/2, which means a is equal to 1/2. But are we solving for a? No. We still have to back substitute and back substitute until we get to x. So kind of like peeling all these layers, and a is x squared divided by x squared plus 1. So this is x squared divided by x squared plus 1. Remember that? Maybe take note, write it down somewhere. If I forget, I'll always go back. Okay, great. Now this brings us to a nicer equation, not to the end yet, so hang in there. But if you do the cross multiplication, we get 2x squared equals x squared plus 1, and then we get x squared equals 1. And from here, tada, be careful, you're supposed to get 2 solutions, x equals 1 and x equals negative 1. Why? Because there are 2 numbers whose square equals 1. Don't mix that up with the square root of 1 because there's only 1 square root. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out aplusbi, and bye-bye.